The authority having jurisdiction, or OJ, is correct in requiring all plugs to be at least 18 inches above the floor in all areas. This is a requirement of the National Electrical Code, or NEC, for hazardous locations. 1200 cubic feet per minute ventilation rate with 6 air changes per hour is sufficient to make the pit area unclassified. This means that the pit area is not considered a hazardous location. The AHA is incorrect in requiring all conduits throughout the facility to be 18 inches from the floor and 18 inches from the ceiling. This requirement is not specified in the NEC for unclassified areas. Once the pit area is made unclassified, there are no remaining classified areas in the facility. The AHA is likely incorrect in stating that the facility cannot work on any compressed natural gas or CNG vehicles. CNG is not considered a hazardous material and does not require special precautions in unclassified areas. To elaborate further on the National Electrical Code requirements for hazardous locations, it is crucial to understand the specific articles that address these areas. These articles provide detailed guidelines for electrical installations in locations where flammable gases, vapors, dust, or fibers may be present. For example, Article 500 covers the general requirements for hazardous locations, while Articles 501 through 506 provide specific requirements for different classes and divisions of hazardous locations. These classifications are based on the type of hazardous material present and the likelihood of its presence in ignitable concentrations. The NEC defines hazardous locations as areas where fire or explosion hazards may exist due to the presence of flammable gases or vapors, flammable liquids, combustible dust, or ignitable fibers or flyings. These locations are classified into different classes, divisions, and groups based on the type and nature of the hazard. Class I locations involve flammable gases or vapors, Class Roman II locations involve combustible dust, and Class Roman III locations involve ignitable fibers or flyings. Each class is further divided into divisions based on the likelihood of the hazardous material being present at ignitable concentrations. Division 1 locations are those where the hazardous material is present continuously, intermittently, or periodically under normal operating conditions, while Division 2 locations are those where the hazardous material is present only under abnormal conditions, such as equipment failure or accidental release. In the context of an oil change bay, the presence of flammable liquids such as gasoline or oil could potentially create a Class I hazardous location. However, if the ventilation system is properly designed and maintained to prevent the accumulation of flammable vapors, the area may be considered unclassified. The ventilation system must provide inadequate airflow to dilute and remove any flammable vapors before they reach an ignitable concentration. Specific requirements for ventilation systems in hazardous locations are outlined in the NEC, as well as other relevant standards such as those published by the American Society of Heating, Refrigerating and Air Conditioning Engineers, or ASHRAE. The NEC also specifies the types of electrical equipment that are permitted in hazardous locations. Equipment must be specifically designed and tested to prevent ignition of the hazardous material. This includes explosion-proof enclosures, intrinsically safe circuits, and other protective measures. Explosion-proof enclosures are designed to contain any internal explosion and prevent it from propagating to the surrounding atmosphere. Intrinsically safe circuits are designed to limit the energy available in the circuit to a level that is too low to ignite the hazardous material. In unclassified areas, the NEC requirements are less stringent than those for hazardous locations. However, there are still general requirements for electrical safety that must be followed. These requirements include proper grounding, overcurrent protection, and wiring methods. Grounding is essential to prevent electrical shock hazards and to provide a path for fault current to flow back to the source. Overcurrent protection, such as circuit breakers and fuses, is designed to protect electrical circuits from overload and short circuits. Wiring methods must comply with the NEC requirements for the type of wiring being used and the environment in which it is installed. Regarding the specific requirement for plugs to be at least 18 inches above the floor, this is intended to reduce the risk of ignition of flammable vapors that may accumulate near the floor. Flammable vapors are often heavier than air and tend to settle in low-lying areas. By raising the plugs above this level, the risk of a spark from the plug igniting the vapors is reduced. The NEC does not specify a general requirement for all conduits to be 18 inches from the floor and 18 inches from the ceiling in unclassified areas. However, there may be local codes or regulations that impose such requirements. It is important to consult with the local authority having jurisdiction to determine the specific requirements for the area. Concerning compressed natural gas vehicles, CNG is not typically considered hazardous material in the same way as gasoline or other flammable liquid. CNG is lighter than air and tends to dissipate quickly, reducing the risk of accumulation in ignitable concentrations. However, there may be specific requirements for working on CNG vehicles, such as disconnecting the battery and venting the CNG system before performing any maintenance or repair work. These requirements are typically outlined in the vehicle manufacturer's service manual or in industry standards for CNG vehicle maintenance. To summarize, when dealing with electrical installations in oil change bays or similar environments, it is essential to understand the NEC requirements for hazardous locations. The proper classification of the area, based on the potential for flammable vapors or other hazardous materials to be present, is crucial in determining the appropriate electrical equipment and wiring methods. Ventilation systems play a critical role in preventing the accumulation of flammable vapors and reducing the risk of fire or explosion. It is also important to consult with the local authority having jurisdiction to ensure compliance with all applicable codes and regulations. Regarding the specific ventilation rate of 1200 cubic feet per minute with 6 air changes per hour, it's important to understand how these figures relate to the overall safety of the pit area. The goal of ventilation in such environments is to dilute and remove any potentially hazardous vapors before they reach a concentration that could be ignited. The required ventilation rate depends on several factors, including the size of the pit area, the rate at which flammable vapors are released, and the desired level of safety. The number of air changes per hour is a measure of how quickly the air in the pit area is replaced with fresh air. A higher number of air changes per hour indicates a more effective ventilation system. The specific number of air changes per hour required for a particular application may be specified in the NEC or other relevant standards. In addition to the ventilation rate, it is also important to consider the location and design of the ventilation system. The air intakes should be located in areas where fresh air is readily available, and the air outlet should be located in areas where flammable vapors are likely to accumulate. The ventilation system should be designed to provide a uniform airflow throughout the pit area without creating dead spots where vapors could accumulate. Regular maintenance of the ventilation system is also essential to ensure that it is operating properly. This includes checking the air filters, cleaning the fan blades, and inspecting the ductwork for leaks. Any problems with the ventilation system should be addressed promptly to prevent the accumulation of flammable vapors. The 18-inch rule for receptacle placement in potentially hazardous areas is rooted in the physics of vapor density. Most flammable liquids release vapors that are heavier than air. These vapors, if released, tend to sink and accumulate near the floor. By elevating electrical receptacles to a minimum of 18 inches above the floor, the likelihood of these receptacles becoming an ignition source in a vapor-rich environment is significantly reduced. It's a simple yet effective safety measure. Now, concerning the placement of conduits, the NEC provides specific guidelines for conduit installation, but generally does not mandate a universal rule of 18 inches from the floor or ceiling in non-hazardous locations. The primary concern is ensuring that conduits are properly supported, protected from physical damage, and installed according to approved methods. Local jurisdictions may have additional requirements, but these are not typically based on a fixed distance from the floor or ceiling unless there are specific reasons, such as preventing damage from floor cleaning equipment or ensuring adequate headroom. When dealing with CNG vehicles, while CNG itself is not considered as hazardous as gasoline vapors because it's lighter than air and dissipates quickly, certain precautions are still warranted. These precautions primarily revolve around preventing leaks and ensuring proper ventilation in areas where CNG vehicles are being serviced. While a blanket prohibition on servicing CNG vehicles might not be justified in an unclassified area with adequate ventilation, it's prudent to follow industry best practices and manufacturers' recommendations for CNG vehicle maintenance. These recommendations often include using specialized tools and equipment, ensuring proper grounding, and being aware of the potential hazards associated with high-pressure CNG systems. Regarding the classification of areas within an oil change facility, it's important to remember that the classification is based on the potential for flammable vapors or other hazardous materials to be present in ignitable concentrations. If the pit area is effectively ventilated, it may be classified as non-hazardous. However, other areas of the facility, such as storage rooms for flammable liquids or areas where fuel is dispensed, may still be classified as hazardous. It's crucial to conduct a thorough hazard assessment to determine the appropriate classification for each area of the facility. This assessment should take into account the types of materials being used, the quantities of materials being stored, the ventilation rates, and any other factors that could affect the potential for hazardous materials to be present. Once the areas have been properly classified, the appropriate electrical equipment and wiring methods can be selected and installed in accordance with the NEC requirements. In summary, navigating the electrical code requirements for oil change bays and similar facilities requires a comprehensive understanding of hazardous location classifications, ventilation requirements, and general electrical safety practices. Consulting with qualified electrical professionals and the local authority having jurisdiction is essential to ensure compliance and maintain a safe working environment. To further clarify the NEC requirements, let's consider some specific examples of how these requirements might apply in an oil change bay. Firstly, suppose the oil change bay uses a solvent parts washer that contains a flammable solvent. The area around the parts washer might be classified as a Class I Division II location, depending on the volatility of the solvent and the effectiveness of the ventilation. In this case, all electrical equipment within the classified area would need to be approved for use in Class I Division II locations. This could include explosion-proof lighting fixtures, sealed switches, and intrinsically safe wiring methods. Secondly, imagine the oil change bay has a storage room for used oil. If the used oil contains a significant amount of gasoline or other flammable liquids, the storage room might be classified as a Class I Division I location. This would require even more stringent electrical safety measures, such as explosion-proof equipment and continuous ventilation. Thirdly, consider the case where the oil change bay uses a compressed air system to power pneumatic tools. If the compressed air system is located in a potentially hazardous area, the electrical equipment associated with the compressor might need to be explosion-proof or intrinsically safe. Finally, if the oil change bay is located in an area where combustible dust is present, such as near a woodworking shop, the area might be classified as a Class Roman II location. This would require the use of dust ignition-proof electrical equipment and wiring methods. These examples illustrate the importance of conducting a thorough hazard assessment and properly classifying the areas within an oil change facility. By understanding the potential hazards and following the NEC requirements, it is possible to create a safer and compliant working environment. Always refer to the latest edition of the NEC and consult with qualified electrical professionals to ensure compliance with all applicable codes and regulations. The authority having jurisdiction, or OJ, plays a crucial role in enforcing these codes and regulations and ensuring the safety of the facility. They can provide valuable guidance and clarification on specific requirements and help to resolve any questions or concerns. Remember, safety is paramount when working with electrical equipment in potentially hazardous environments. By taking the necessary precautions and following the NEC requirements, you can minimize the risk of fire, explosion, and electrical shock.